Okay, we are recording. Just a reminder, you're here to check day one's classwork, and then I will also have day two's lesson as well as classwork on here. Normally, it'll just be a place to check your classwork, but because I will be gone, your lesson for Friday is on here as well. So we work through some of these technical difficulties first, and we should be, but we are not ready to go because once we turn the slideshow on, we need to turn the pen on. And now we are good, hopefully. Okay, let's get back to, there we go, problem one. Okay, so there's my pen. Now, I know I'm going to go too fast through this. That's okay. Just as I go too fast, just pause, go slower, slow down the speed or speed me up and fast forward to the problems you are having trouble with. Okay, so draw a border on both sides. -2 is keeping both sides from being alone. Cross that off. So now you have 12. 4x equals 12. We need to divide both sides by 4. So x equals 3. You guys can't see is that my face is in the way of the next problem. Okay, on this side, I would suggest combining 6 and 3 to make this 9 plus 4x on this side equals -11. What's keeping x from being alone? Well, the 9 is. Let's get rid of it by subtracting. We have 4x equals -11 minus 9, which is -20. Divide both sides by 4 because that's what's keeping x from being alone. X equals -5. Okay, I would recommend on this next problem actually dividing the 3 out first. If you distributed it, that's fine. You should get the same answer, but I recommend getting rid of that 3 now because I can. And we have 6 equals, now that gets rid of what's on the outside of the parentheses. 3x minus 6 now is there. Now it's keeping x from being alone at -6 over there. Add 6 to both sides. 12 equals 3x. Now 3 is keeping it from being alone, and it is multiplying. So we need to do the opposite, which is to divide. X equals 4. Take 25 away from both sides. Careful with these negatives. This makes it -35 over here. 35x equals -35. 35 is multiplying by x. Divide by 35. Careful here. Keep track of that negative. X equals -1. Okay. Similar to previous, we need to combine these first. I would say 13, 8 plus 5 is 13 plus 4x equals 53. Take 13 away from both sides. 40 equals 4x. And again, if you already checked this with me on Thursday, you can fast forward this and just go straight to the next lesson. 5 by 4 on both sides, x equals 10. Okay, these ones get kind of difficult. Not that, even if it's tough, get rid of the easy thing first. Get rid of that +5 on both sides. We have x over 7, which I get looks funny. We're trying to get rid of that 7. It's currently dividing, so multiply both sides by 7. Cancels out right there. 7 times 7. It doesn't matter. There's one in the numerator, one in the denominator. They get rid of each other. X equals 7 times 7, which is 49. Those ones are tougher. Plug it back in. 49 divided by 7 is 7. -5 plus 7 would be 2. So you can always double check your work. All right, here's the lesson that I will be absent for. So the expectation is that you do the notes. And then when I come in on Monday, you should have the classwork checked and done and ready to get credit for, it. Okay, so if there are variables on both sides, which there are here, what we need to do is get them all on one side. Numbers on one side, variables on the other. Divide this side right here in two. I want the 4K to move over here. What I need to do then, if I have positive 4K here, I'm going to take it away from both sides. So I get rid of 4K on one side, 7 minus 4. Now I have 3K equals 15. I don't want 3K. I want 1. So I divide both sides by 3 to have 5. Okay, again, right here, I have 3x on one side, 5x on the other. It wouldn't matter which one if I decided to move the other one. I just like to move the x's to one side and keep them positive if I can. So if by taking 3x away over here, it gives me 5 minus 3, which is 2x minus 2 equals 4. And now all I have to do is get rid of the 2 over here. So now I have 2x equals 6. Divide both sides by 2. X equals 3. Kind of running out of room with the Zoom tools here. I'll figure that out as the year goes on. Again, the things I'm talking about, you guys can't see, but I have to move my face so I can see this problem. Camera, that is. It stays in one spot for you, not for me. All right. Even though before I liked getting rid of these numbers by dividing first, if you're trying to get variables on both sides, it's probably best to distribute first. So 2y times 2 be 12. Why do we do that? Just because it makes things easier once we take 3y away from this side. Actually, let's not do that. Let's take 2y away because then I can avoid negatives. 3y minus 2y, and that gives me 1y equals 12. If I would have done it the other way, it would have been fine too. I would have had negative y equals negative 12, so positive y equals 12, but I'd rather deal with positives if I can. 3 times 1 is 3. 3 times negative 3x, negative 9. X equals, again, distribute that 2, negative 8x. 2 times 7 is 14. It gets kind of funky with positives and negatives here. I would say adding 9x will make this easier because it gets rid of the x's on the left. When I add 9x to the right-hand side, then I'm left with just a single x plus 14 is still there. No more x's on the left. That's good. So there's just a 3. Now I just have to take the only thing keeping x from being alone is this 14. Take it away from both sides. 3 minus 14. You can't always avoid all the negatives. 3 minus 14 is negative 11. All right, so some of these get a little different. Negative 6x plus x, so we have negative 5x plus 4 equals negative 5x. What's 6 minus 2? It's also plus 4. Now, if these equations are the same on both sides, so we should stop right there and see. This means you have all real numbers. Let's one way to say it. You could also say infinite solutions. Because no matter what number you plug in there, it's always going to work. You're going to multiply it by -5, then add 4, and it's going to be the same thing on both sides. You're treating everything the exact same. So, I mean, if we went one step further and I added 5x to both sides, so there's no 5x on the left, there's no x's on the right either. So now we just have 4 equals 4. Well, when is 4 going to equal 4? Always, no matter what. So that's why we get infinite solutions are all real numbers. Okay, now let's look here, -8x plus 9x, and you would have x, right? 9 minus 8 is 1, yep. And then plus 6 equals -17 plus x. Now, this is another one where we could stop and say, okay, is adding 6 to something ever going to be the same thing as taking 17 away from that very same thing? That will never be true. So this is no solution, because it's never going to be true. Now, again, if you went that next step, if you decided, okay, let's get all the x's out of this side. So we take x away from both sides. Now we don't have any x's. We just have 6 is equal to -17. Well, is 6 ever equal to -17? No, it's not. So this will never be true. It's never true. So there's no solution, right? Because 6 does not equal 17. Okay, why would an equation have no solutions? Again, because something is when something can never be true. It's like asking, when are these parallel lines going to cross? Never. Okay. How would an equation have solution of all real numbers? That's when something will always be true. Let's use the parallel lines scenario. So if someone leaves the finish line of a race and someone leaves at the exact same time, use another color, leaves at the exact same time and runs the exact same race. Well, when are they tied? They're always tied. You're always going there. So something that's always going to be true, it's all real numbers, never going to be true, no solutions. All right, just a couple classwork problems, and make sure you turn these in to me when I return on Monday. Let's stick with the green, why don't we? Okay, variables on both sides. Take 6r away here, and we have, and I know I'm going fast. Slow it down, watch it again. 7 equals 13. 7 minus 6 is r. Take 13 away from both sides. Show all your work if you want to get your credit. And you have r equals 7 minus 13. That's -6. 2x plus 6. When is that going to be the same thing as 2x plus 5? I don't even have to do any work here. I can just say 2x. These are like parallel lines that won't cross. Okay, this is no solution. If you want to check here, take 2x away from both sides, get rid of it. Is 5 ever equal to 6? No, it's not. Okay, 7 times, we got 35y, -28 equals 15 minus 8y. Get all your y's onto one side. I'm going to add 8y to both sides. 35 and 8 makes 43y minus 28 plus 28 on both sides. And we have 43y equals 43. I'm going to use some more space here. Divide both sides by 43. Y equals 1. All right, distribute the 4. And this last one, let's change colors because they're blending together. 4 times 4, 16x plus 12 plus 8x, right? That was also there. Equals 24x plus 16 minus 4. Okay. 8x and 16x, that makes 24x. Okay, red flag there. Plus 12 equals 16 minus 4. So again, we have 24x plus 12. When are these the same? Always. All real numbers. You would say infinite solutions. I think that's the last problem. Yes, it is. And then we'll do that on Monday. All right. See you guys Monday.